Now let's just move on further towards some other criteria for the congruence of the triangles. As you have already seen in the question, I have used a congruence criteria which is nothing but SSS congruence criteria, that is side, side, side. So yes, that congruence criteria do exist, and now I am going to prove that SSS congruence criteria under this topic, which is nothing but some more criteria for the congruence of the triangle. So hence the SSS congruence criteria or the rule says that, it says that if three sides of a triangle are equal to the three sides of another triangle, then the two triangles are congruent to each other. So you have already seen that I have used this SSS congruence criterion in one of the question, and does this rule do exist, and now I am going to prove this. So let's just start the proof of this particular criteria. First of all, I'm just taking the two triangles over here. So let us suppose if I'm just starting with the given condition. So given is nothing but a triangle PQR and a triangle XYZ. So let us suppose if I'm just taking the two triangle PQR and XYZ such that their sides are equal. So let us suppose if I'm just taking the two triangles over here. So this is my PQR, this is nothing but my PQR, and this is nothing but my XYZ. This is nothing but my X, Y and Z. So such that PQ is equal to XY, further PR is equal to XZ, and further QR is nothing but is equal to YZ. Means this side is equal to this side is equal to this side, and this side is nothing but is equal to this side. So hence this is nothing but a given condition to us, and now we have to prove that these two triangles are actually congruent to each other. So let us suppose if I'm just writing it over here, that I'm just doing a little bit of construction over here in order to prove that these two triangles are congruent. I'm just taking any XW, I'm just drawing an XW particular line segment such that in such a way that let us suppose if I'm joining this particular angle over here. So I'm just constructing or drawing this XW intersecting YZ in such a manner that this angle is nothing but is equal to this angle. So I am just doing this construction of XW side in such a manner that this angle is equal to this angle, and this Y, or we can say WY, is actually nothing but is equal to this PQ. So let us suppose if I'm just talking about this PQ such that this is nothing but is equal to YW. This is nothing but is equal to YW or WY. So let us suppose if I'm just again joining this WZ. So let if I'm drawing, if I'm writing all the construction that I have done over here, that draw XW intersecting, draw XW intersecting YZ in such a manner that angle WYZ is equal to the angle PQR, and WY is nothing but is equal to PQ. WY is nothing but is equal to PQ. So I am just doing this construction in such a manner. Now let's just move on further, and let's just write what we have to prove over here. So let us suppose if I'm just writing it over here, that what we have to prove, we have to prove that the two triangles are congruent. Means the triangle PQR is congruent to the triangle XYZ. Now let us suppose if I am just starting with the lower triangle, that is nothing but the triangle which is WYZ and PQR. So let's just start the proof of this particular theorem by taking in triangle PQR and triangle WYZ. I'm just taking WYZ and PQR. So since in these two triangles, first of all we know that first condition is PQ is equal to WY. We know this by construction. We have drawn them in such a manner that the sides are equal, and furthermore the second thing over here, we know that the angle PQR is nothing but equal to the angle WYZ. Again, this is by construction. this is by construction. And the third thing, we already know about this thing, that the QR is nothing but is equal to YZ. QR is nothing but is equal to YZ. So this side is equal to this side, this angle is equal to this angle, and this side is actually is equal to this side. So what can we say from these three things? That the triangle PQR is nothing but congruent to the triangle WYZ by S, by side angle side congruence criteria. Obviously you can see over here that this is nothing but a side angle side congruence criteria. So hence from this, the two triangles are congruent to each other. So hence if the two triangles are congruent to each other, it implies that angle W is nothing but is equal to the angle P. Angle W is nothing but is equal to the angle P. This angle is nothing but is equal to this angle. This angle is nothing but is equal to this angle. We can say this thing, that this angle is equal to this angle by CPCT. By CPCT, let us suppose if I am taking it as nothing but the equation number 1, because this is of great use to us. So we have taken over here that angle W is nothing but is equal to the angle P. Now let's just move on further towards the other triangle over here, which is nothing but X, which is nothing but, I'm just taking the triangle as XYW. I'm just taking this triangle over here. So let us suppose if I'm just taking this as nothing but angle 1, I am taking this angle as nothing but angle 2. So let us suppose if I am just taking this angle as nothing but angle 2, I'm taking this angle as angle 3, and I'm taking this angle as nothing but angle 4. Let us suppose if I'm just taking them in such a manner. So if I'm just starting with in triangle, what can we say about the triangle XW, X, Y and W? So what can we say about these two triangle? Means in the triangle X, Y, W, let us suppose if I'm just taking this triangle, in triangle X, Y, and we have the other triangle as nothing but W. In the triangle X, Y and W and the triangle, we can say the other triangle as nothing but P, Q and R. We are taking the triangle P, Q and R. First of all, we can see over here that what can we know about this particular triangle. Let's just talk about this triangle. We know that this XY is actually is equal to PQ. We already know about this thing, that this particular side is actually is equal to this side. We already know about this particular concept, that this side is actually is equal to this side. And furthermore, what can we say about the other things? So as you can see, there is only one such condition in between the two triangles, that the side PQ is actually nothing but is equal to XY. PQ is actually nothing but is equal to XY. So what we just wanted to take from these two triangles, actually we are mostly concerned about this particular triangle. Here we just wanted to prove that this particular angle is equal to this particular angle. So that's why I have taken this triangle and this triangle, and I'm just comparing these two triangles in order to show that this angle is equal to this angle. So as you can see over here that from these two triangles we can say that XY is nothing but is equal to PQ. XY is nothing but is equal to PQ, and furthermore we know that PQ is nothing but is equal to WY. We already know about this thing, that PQ is actually nothing but is equal to WY, as this is nothing but by construction. This is nothing but by construction. You can see over here that this is nothing but by construction. So hence from these two things, what we can conclude? We can conclude that XY is nothing but is equal to WY. XY is nothing but is equal to WY. So if XY is nothing but is equal to WY, it means that the angle 1 is equal to the angle 2. Why so? Because the angles opposite to equal sides are equal, and in the similar manner, let us suppose if I'm just taking it as 2, and in the similar manner, similarly I can prove that in the triangle XZW, again I can prove that angle 3 is equal to the angle 4. Let us suppose if I'm just taking it as the angle 3. Now let us suppose if I'm just add equation number 2 and 3. Let us suppose if I am adding the second equation and third equation. So I am getting angle 1 plus angle 3 is equal to angle 2 plus angle 4, angle 2 plus angle 4, and we know that angle 1 plus angle 3 is actually nothing but the whole angle, angle x, and angle 2 plus angle 4 is nothing but the whole angle, which is nothing but angle w. So hence at the end we are getting angle x as nothing but is equal to angle w. Let us suppose if I am taking it as nothing but the equation number 2. I am taking it as the equation number 2. Now furthermore, you can conclude from the equation number 1 and 2 from the let us suppose if I am just taking it as 4, because I have already taken 2 and 3 and 4. So what can we conclude from the equation number 1 and 4? That angle x is equal to angle w is equal to the angle p, which implies that angle x is equal to the angle p. Angle x is equal to the angle p, which is the most important result that we have together. Let's just start with the triangle. In triangle PQR and the triangle XYZ. So again, let us suppose if I am just taking the two triangles over here. So we know that PQ is nothing but is equal to XY. Furthermore, we know that angle X is equal to angle P. This is nothing but already proven above, already proven case, and this is nothing but a given case. And further, we know that PR is nothing but is equal to XZ, which is already again given. So what can we say about these three conditions? Since you can see that this is nothing but side angle side by SAS congruence criteria, the PQR triangle is nothing but congruent to the angle triangle XYZ by SAS, not SAS. This is the thing that we have to prove, that is SSS congruence rule. So by side angle side by SAS congruence criteria, we have proved that the two triangles are actually congruent to each other. So this is nothing but the proof of this theorem, in which we have proved that the triangle PQR is actually congruent to the triangle XYZ, and this is all about SSS congruence rule. So always remember, whenever the three sides of a triangle are equal to the three sides of another triangle, then the two triangles are congruent. And using this concept, I have already proven one question before, that when the three sides are congruent to the three sides of another triangle, then the two triangles are congruent to each other. Now let's just move on further towards the another criteria for the congruence of the triangle, which is nothing but called as the RHS congruence rule. RHS congruence rule. So what does it says? It says that if in two right triangle the hypotenuse and one side of a triangle are equal to the hypotenuse and one side of other triangle, then the two triangles are congruent. So let us suppose if I'm just taking the two right angle triangle over here as nothing but A, B, C and D, E, F. Let us suppose if I'm just taking the two right angle triangle over here, this is D, E, F, which is right angled at E, right angled at B. So we know that this side is actually is equal to this side and hypotenuse is equal to the hypotenuse. So we know from this given condition that one side and the hypotenuse is equal to the one side and the hypotenuse of another triangle. So let us suppose if I'm just writing it over here, that given a right angled triangle, ABC and a triangle DEF, such that AC is nothing but is equal to DF and BC is nothing but is equal to EF. Let us suppose if I'm calling it as 1, I'm calling it as 2. So what we have to prove over here, we have to prove that the two triangles, that is triangle ABC is congruent to the triangle DEF. This is a thing that we have to prove. So let's just start the proof of this one. Let's just start the proof for this. So first of all, as you can see in the triangle ABC, in the triangle ABC, we can say that AC square is equal to AB square plus BC square, since I am applying the Pythagoras theorem. By Pythagoras theorem, we can say this thing, that the hypotenuse square is equal to the sum of the squares of the other two sides. And similarly, let us suppose if I am just calculating AB square out of it. So AB square is nothing but AC square minus BC square. Let us suppose if I am just calling it as nothing but my equation number 3rd. Now in the same manner I can just talk about the other triangle, which is nothing but DEF. So furthermore, in triangle DEF, again we can say that DF square is equal to DE square plus EF square. Again we can say this by Pythagoras theorem, and furthermore I am just calculating DE square out of it, which is nothing but DF square minus EF square, and let us suppose if I am just taking it as nothing but the equation number 4. And furthermore you can say this thing that if it is DE square which is equal to DF square, then in place of DF I can write AC square, in place of EF I can write BC square. Definitely I can write this thing. Why so? Because since we know that AC is equal to DF, and furthermore we know that BC is equal to EF. So in place of EF and DF I can write AC and BC. Furthermore we can say that this is DE square, which is nothing but is equal to AB square. Why so? Because from the equation number 3rd we know that this value is actually nothing but is equal to AB square. Let us suppose if I am just neglecting the square, so DE should be is equal to AB. So DE should be is equal to AB. So we are getting that DE is nothing but is equal to AB. Means we are getting that this side is actually is equal to this side. So now the result to prove that the two triangles are congruent is easy to us. Let's just start with in triangle ABC and triangle DEF. We know that AB is equal to DE, which is already proven. So furthermore we know that AC is equal to DF and BC is equal to EF. This is nothing but given. So from these three things, what can we say? We say that the triangle ABC is congruent to the triangle DEF by SSS congruence criteria. It implies that the two triangles are congruent, and this is the thing that we have to prove over here, that this is nothing but the RHS congruence rule, which says that if in two triangles, right triangle only, we are just talking about the right triangle over here. In the right triangle, the hypotenuse and one side of a triangle, if they are equal to the hypotenuse and one side of another triangle, then the two triangles are always congruent. This is all about RHS congruence rule.